Hello everybody, welcome to my channel. Today I will discuss one of the important topic in the domain of civil engineering, that is nothing but metacentric height and center of buoyancy. This term is very useful while designing the ships and submarine because metacenter is the point which is responsible for the stability of a floating body, whether it is submarine or it is a ship. So before going to discuss metacentric height, we should be very familiar with this principle and these basic terms. So this video may be very long, so I will divide it into two parts. In first part we shall discuss these basic terms. In the second part we shall jump to understand the metacentric height and center of buoyancy. So before moving further, I would brief Archimedes principle. In general, you might have studied this principle in your earlier classes, yet I would describe it briefly. So Archimedes was a famous mathematician, physicist and philosopher from Italy. He did a lot of work in the domain of hydraulics. So what is Archimedes principle? Archimedes said when a body is partially or fully immersed in a liquid, there is a loss in the weight of the body. You might have experienced these things in your daily life. So Archimedes explained that this loss of body in a liquid is nothing but equal to the weight of displaced fluid. Okay. So let's take an example. Suppose we have a spherical ball and we immerse this ball in liquid partially. And for example, the portion of the spherical ball which is immersed in liquid is V1. V1 is the volume, V2. So V2 is the volume in liquid of the body and V1 is that volume which is in air, volume in air. So total volume of the body is equal to V1 plus V2. So according to the Archimedes principle, loss in weight of body is equal to weight of displaced fluid. The weight of displaced fluid is nothing but the unit weight of fluid into immersed volume V2, that is immersed volume. Same thing. In other words, we can say this loss in weight of the body is nothing but the buoyant force. So buoyant force is equal to loss in weight of body, that is nothing but gamma fluid into immersed volume. And you can easily detect this buoyant force will be working from downward to upward because it is decreasing the weight of the body. So buoyant force work from downward to upward, and weight of the body will always act towards the center of the earth, whether body is in air, in liquid or wherever it is. So weight will always act downward. So there is a loss. What is the new weight of the body in liquid? So weight of body in liquid or fluid, whatever you call it, is nothing but weight, original weight, natural weight minus loss in the weight of the body, that is nothing but the buoyant force. So the net force of the body inside the liquid is W minus FD. I think these two terms might have been very clear to all of you. I explained each and everything. Next thing which comes into picture is center of buoyancy. What is center of buoyancy? People get confused between center of buoyancy, center of pressure, center of gravity, and metacenter. But I will describe these terms one by one, and I will try to make it clear to all of you. So next point is, what is center of buoyancy? Center of buoyancy is nothing but the center of gravity of displaced fluid. It means it is nothing but the center of gravity of this portion which is partially immersed inside the liquid. So for example, this this is, if you consider is half of the spherical portion, then what is the center of buoyancy? Center of buoyancy will be the center of gravity, this hemisphere, center of buoyancy. We shall again discuss it in coming scenario, that is metacentric height. So I think these two terms might have been very clear to all of you. Next topic is different equilibrium. So the equilibrium, this thing I think you have studied in your 10th or 12th classes. The equilibrium can be divided into three distinct categories. First is stable equilibrium, second neutral equilibrium, and third one is unstable equilibrium. So what does stable equilibrium mean? For example, we have this frame and this is spherical ball, and if I displaced it towards left hand side in this way, then body will automatically regain its original position. It will come back to its original state. Whether I displace it in a right side, body automatically will come into the its original state. This is known to be stable equilibrium. Second thing is neutral equilibrium. What is neutral equilibrium? If we have a spherical ball lying on a horizontal plane, and if we displace it towards right side or if we displace it towards left side, it will take the next position, displaced position, very easily. It will not come back to its original state. So this is known to be the neutral equilibrium. Wherever you move the body will move there very easily and it will not come back to its original state. This is known as neutral equilibrium. Third point is unstable equilibrium. As picture reveals that, you get very easily, this is the example of unstable equilibrium. If we slightly displace body here and or here or there, it will easily move in this way or in this way, and it will never come back to its original state. It will move forever. Okay, so this is known as unstable equilibrium. These three types of equilibrium might be very useful to understand metacenter and metacentric height. So now I move further. Next topic is linear stability of floating body. What is linear stability? For example, I have this liquid surface and there is a body partially immersed in this liquid. This body is A, B, C and D. For example, if I give it a linear displacement vertically, In other words, I dip this body vertically downward inside the liquid, then it will take a new position, that is A dash, B dash and C dash, D dash. This experiment you might have done frequently in your early life. Whenever we dip this body inside the liquid, it again comes back to its original state. It regains its original state. This and this. So this is called linear stability of the body. Okay. Again, there are two things which comes into picture. First is vertical stability and second one is horizontal stability. So if I dip this body inside the liquid, it will again regain its original state. So this is called vertical stability, and this stability is nothing but the stable equilibrium. Vertical stability is nothing but stable equilibrium because it regains its original state. Second, horizontal stability. Now I move this body right hand side. If I move this body right hand side, then it will not come back to its original state. It will be easily moved into its new position. So this is called horizontal stability, and horizontal stability is always neutral equilibrium. As I explained earlier, what is neutral equilibrium? The body easily takes new position and it does not come back to its original state. So in short, linear stability of floating body, it is in stable equilibrium if I move this vertically, and it is in a neutral equilibrium if I move this body horizontally. I think this thing might be very clear to all of you. Now I move further. That is rotational stability of body. This is very important terms to understand metacenter and metacentric height. What is rotational stability? Again same body, A, B, C and D. If I give a little rotational displacement to the body, it will take this shape. That is A dash, B dash, C dash and D dash. So I gave a little rotational displacement to this body. Now this is, for example, center of buoyancy, and this is, let's suppose, center of gravity. Okay. So when I give a little rotational displacement, there would be a buoyant force working from downward to upward, as I explained it earlier. So at this point, this will be the buoyant force and this will be the weight of the body. And these two forces must be equal because body is floating. And what is the principle? If body is floating, the buoyant force must be equal to the weight of the body. Now point to be noted. When the body was vertically immersed, okay, when the body was vertically immersed, the center of buoyancy CB and center of gravity, both lies in a vertical line. Both are one below is the another one point is below the another point. But when I give a little rotational displacement of the body, center of gravity never changes. Center of gravity does not changes because center of gravity is a fixed point. But when I give a rotational displacement, the center of buoyancy changes because center of buoyancy is nothing but the center of gravity of displaced fluid. And if I rotate this, the amount of the displaced fluid will be something different. And that's why the center of buoyancy changes. First, this might be the center of buoyancy, and when I rotationally displace it, center of buoyancy comes to this point. So there is a distance x. There is a distance x between center of buoyancy and center of gravity. So these two forces, buoyant forces and weight, these two forces makes restoring couple. Restoring couple. What is couple? Couple is the two forces of equal amount which works opposite to each other. So these forces, buoyant forces and weight of the body, makes the restoring couple, and these couple tries to bring body back into its original state. So that's why if I give a slight rotational displacement, body will regain its shape again. Why does this happen? Because the restoring couple made by the buoyant force and the weight of the body regains the body to its original state. So this is the rotational stability of the body.